Welcome to Lesson 10, a masterclass where we'll recreate one of the most iconic and influential architectural works by Ludwig Mies van der Rohe, the Barcelona Pavilion. In this session, we'll build the entire project from the ground up, all the way to the final render. You'll find the project blueprint included in the course files. Using it as our guide, we'll walk through a complete production workflow, starting with modeling, followed by texturing, lighting, and rendering. I'll clearly explain each step and introduce any new techniques we use along the way. This masterclass is divided into two parts. In the first part, we'll model the pavilion based on the blueprint and apply all necessary textures. In the second part, we'll set up the environment and complete the final render, including using V-Ray fur to create realistic grass for the exterior. Let's bring the blueprint into the scene. From the top view, we'll use the line tool to trace out the base of the project. This will serve as the foundation for the rest of the structure. Just follow along with what you see on screen. For now, we can skip the staircase. We'll create it later as a separate object. Next, we'll give the base some thickness using the shell modifier. From the front view, let's align it accurately with the blueprint. The project includes two pools. We'll cut their shapes into the base using the Shape Merge tool. You'll see exactly how this is done. Start by selecting the rectangle spline from the Shapes menu, and draw the outlines of the pools separately, just as they're shown in the reference. Now, select both of the newly created rectangles along with the base object. To better see what we're doing, isolate the selection. Then, in the command panel, switch from Standard Primitives to Compound Objects and choose Shape Merge. This allows us to project the outlines of the selected shapes onto the surface below, creating polygonal cutouts based on those forms. Once the cutting process is complete, we can delete those shape outlines and return to our blueprint. Let's begin extruding the walls based on the drawing, using the plane edge dragging method. As a reminder, if the snap target is far from the edge you're dragging and you need to reposition the viewport while dragging, simply don't release the left mouse button. Instead, hold it down and move the viewport using the middle mouse button. This way, you can drag the polygon and adjust your view at the same time. Once you've completed the wall layout, apply volume using the shell modifier and set the height to 3 meters. Convert the object to editable poly and reset the smoothing groups to keep everything clean. Repeat this same process to build the wall on the opposite side. Now, let's slightly lower the areas where the pools are located. According to the blueprint, these parts are not very deep. Let's switch to the side view and use the line tool to create the staircase that will be placed inside the cutout. Once the shape is complete, apply a shell modifier and use the vertices to fit it precisely to the opening. Let's continue extruding the walls, making sure to cover every part of the blueprint intentionally. Next, we'll create the cross-shaped metal columns. Before giving them thickness, we'll round their corners using the fillet option. If a corner doesn't round symmetrically, as in the current bottom right corner, it means the vertex type needs to be corrected. Select all the corner points, right-click, and set them to corner. As you can see, everything is now fixed. Now duplicate these columns and place them exactly where they are shown in the blueprint. Now select everything we just created and lower it to its proper height. Let's use the selection filter located in the drop-down menu at the top left corner of the interface. This allows you to control what can and cannot be selected. Choose geometry so we can easily select only our columns and walls to position them onto the base. With this filter active, lines, shapes, and any other non-geometry objects will not be selected. You can also choose to filter for splines, lights, cameras, or other specific object types, depending on what you need to work with. According to the blueprint, there's a minimalist stone bench running along the entire wall. Just follow its shape. From the front view, adjust the height to match the blueprint accurately. Keep in mind to chamfer sharp corners during modeling whenever possible. Let's adjust everything according to the blueprint and group the objects so we can easily manage them later. Now let's move on to creating the roof structures, and then we'll start modeling the window frames. Let's make use of mass copying wherever we can, especially if the objects are evenly distributed. Let's take a look at the horizontal part of the frame. To save time, we can create a single horizontal frame and pass it through the verticals. As a result, there will be no noticeable difference. Set the height to 7 centimeters and continue assembling the remaining parts. Once that's done, we'll select all the frame elements and apply a chamfer modifier with a very subtle radius, around zero point 0.3 centimeters. After that, we'll group everything together. As you can see, the object is almost complete. Just a bit of final tweaking remains before we move on to texturing. Now let's create the glass panes and insert them into the frames. Each pane should be 1 centimeter thick. For better visual contrast, change the frame color to black. Switch to the top view and continue refining the remaining components. This part will follow the same process as before. Now it's time to start creating the tiles on the walls. To do this, we'll begin by dividing the surface into sections. As usual, we'll use the Connect tool. Seven vertical segments should be enough, and we'll need just two horizontal ones. Next, select all the created sections and in By Polygon mode, apply an inset to each one at around zero point 0.5 centimeters. After that, apply a slight extrude of 1 to 2 centimeters to create the effect of fine separation lines between the tiles. We can also apply a chamfer modifier if we want to slightly round the edges. However, polygon smoothing is incorrectly interpreting the tile surfaces as rounded. To fix this, add an Edit Poly modifier to the modifier stack. Select all polygons and reset the smoothing groups by clicking the Clear All button. We're making great progress. The model is almost complete. Now let's begin applying textures and refining the materials. First, select all polygons of the base model except for the fountain's base. Then create and assign a stone tile texture to them. If you don't have textures available, I recommend pausing the video and doing a quick search for Ludwig Mies van der Rohe's Barcelona Pavilion to understand what materials were used in the real structure. Once you have an idea, look for similar textures online, either from free resources using Google or by purchasing high-resolution 4K or 6K textures. Personally, I use the Arroway Textures packs. This is not a promotion, just a suggestion based on my workflow. If everything is ready, go ahead and create the appropriate material. Don't forget to add a color correction node before connecting your diffuse map. This gives you more control over the brightness, contrast, and overall tone of the texture. To better preview the textures on the red highlighted polygons in the viewport, press F2. This will make the red selection transparent and help you see the texture beneath more clearly. Next, apply UVW map to the surface and adjust coordinates as needed for a clean fit. Let's also refine the material properties. For the reflection, I'll be using a dedicated reflection map, and just like with the diffuse, I'll place it through a color correction node. This allows me to easily control the brightness of the reflection map, which directly affects the reflectivity strength of the material. Additionally, reduce the glossiness value to soften the reflections and create a more natural transition in highlights. We'll also need a bump effect here. To do that, let's use a V-Ray normal map node. First, connect your normal map texture to the bump input of the V-Ray normal map. You can also add a regular grayscale bump texture if you have one. Assign individual intensity values to both maps. Something like 3 to 5 depending on how strong or contrasted your bump maps are. Exit the node and set the overall bump strength to around 3. Now let's apply the same method to the wall texture. The wall shares the same material as the bench, so we can assign the same texture to both objects. After that, we'll move on to refining the material properties for this shared surface. Let me show you an interesting way to select multiple objects more efficiently. Let's say we want to select all the cross-shaped metal beams. Start by selecting just one of them. Then, right-click and choose Select Similar. After that, click the Isolate Selection button to keep only the selected objects visible. However, as you'll notice, the Select Similar function isn't always perfect. In this case, it also selected parts of the wall along with the metal beams. Most likely, it recognized similarities because the walls were created using splines combined with a shell modifier, just like the beams. To fix this, simply deselect the unwanted elements and continue working with the beams only. Now let's create a metallic reflective material, something resembling aluminum, which we'll use for both the beams and the window frames. At this stage, we're just building the base of the material. We'll fine-tune it later during the interactive rendering. Once the material is applied to the beams and window frames, we'll move on to creating the glass material for the window panes. According to the project reference, these two windows are meant to have a more frosted or blurred appearance. Let's select them and create a separate glass material just for these panes. Then reduce the refraction glossiness to zero point 0.7 to give them a softer, less transparent look. This will simulate the effect of frosted or semi-opaque glass while still maintaining realism in the reflections and lighting. Let's place the camera and slowly start working on the scene view. In the camera settings, select a focal length of 40 millimeters. The lower the focal length, the more stretched the perspective lines become. When you want to achieve a more distorted, wide-angle perspective and also include more of the scene in the frame, you can use lenses with a shorter focal length, like 16 millimeters or 18 millimeters. Personally, I prefer when the perspective lines appear closer to parallel, which is why I often use lenses in the 40 to 70 millimeter range, especially for architectural renders. Let's add a dome light to test the scene and see what we're working with. We'll tweak the intensity a bit to get a better balance. You can enable the invisible option for the light. This will remove the bright, burned-out white background while keeping the lighting effect. This setting is usually more useful for post-production, but at this stage it might be better to add and make the HDRI map environment visible in the background. As long as this wall is still pink, nothing else in the scene really stands out visually. So, let's go ahead and start working on the wall. We'll create the tiles using the same principles we used earlier. When polygon selection is active, you can enable bi-angle to quickly select connected polygons based on their angle. If the angle between polygons is lower than the set value, they'll be selected together. It's great for selecting flat surfaces or grouped faces without clicking each one manually. Hold Control and select all three inner surfaces. Then apply Inset by Polygon, and after that use Extrude. Now let's create and apply a green marble material. In Van der Rohe's project, the marble walls are designed so that the tiles mirror each other's patterns. Let's try to create a similar mapping effect. After we adjust the UVW map modifier as needed, we'll add another Edit Poly modifier on top of the modifier stack. Using this, we'll select the polygons where we want the mirror effect to appear. Next, we'll duplicate the existing UVW map modifier. To do this, right-click on it and choose Copy. Then right-click on the newly added Edit Poly modifier and select Paste. This will copy all the settings from the UVW map modifier, so we won't need to manually tweak everything again. The only thing we need to change is the coordinate axis we want to mirror. For that axis, we simply enter a negative value. In this case, it's the length coordinate, so instead of 400, we type negative 400. Then, activate the UVW map modifier and drag to find the perfect mirror point. Right now, I performed this operation on just 3 polygons as a demonstration. If I had selected other polygons at the same time, they would have been mirrored too. But let's go through it step by step, so the process is easier to remember. This time, let's create another layer for the adjacent polygons. We'll repeat the process from the beginning and add another Edit Poly modifier to the stack. Copy UVW map, and so on. Now, let's work on the material. We want a nice glossy marble surface. So let's add a bit of coat. Marble looks great with an extra reflective layer. We can adjust the color to our preference and slightly reduce the glossiness in both the reflection and coat parameters to give it a more realistic look. Now let's improve the lighting by connecting an HDRI map to the dome light. To control it, drag the HDRI into an empty material slot in the material editor as an instance. Next, go to Rendering, Environment, and in the pop-up window, drag your V-Ray bitmap into the Environment Map slot as an instance, just like shown on the screen. This will make the HDRI visible in the viewport. You can rotate it and make other adjustments directly in the V-Ray bitmap settings inside the material editor. If the HDRI map doesn't show up in the environment background, go to the top left plus menu in the viewport and choose Configure Viewports. Then switch to the Background tab and enable the option Use Environment Background. Right now, the ceiling is blue, but white would probably look better. Let's create a white material and increase the roughness all the way up to give it a chalky, matte ceiling effect. A bit of reflection would also help, but keep the glossiness low so it doesn't appear too shiny. We need to place sea pebbles on the bottom of the pool. Start by copying the bottom polygon and detaching it as a separate object. We'll use the V-Ray displacement mod along with a normal bump material. Make sure to apply proper UVW mapping and refine the material settings. The displacement intensity should be between 2 and 5 centimeters, depending on the contrast of your displacement map. Above the stones, we need a water surface. Switch to top view and create a new plane with a high number of segments. This will allow us to apply a noise effect for subtle surface ripples. Let's add a noise modifier to the water surface. Set the scale around 30 depending on how strong you want the distortion. For the z-axis strength, 1 centimeter is a good starting point. Now let's create a water material. This is a great moment to explain fog parameters, which are ideal for water or tinted glass. Set the diffuse color to black and both reflection and refraction to white. Set glossiness to 0.98 for both. Below, in the translucency section, you'll see that when it's set to none, the fog settings become visible. Fog controls how light scatters inside transparent objects. It adds color depth to glass or liquid based on thickness. Let's choose a watercolor in the fog color slot. Keep in mind that fog color is very sensitive. Even a 1-unit change can make a big difference. You might like how it looks in the material preview, but it can appear different on the object due to its thickness. That's why it's best to adjust fog while using interactive rendering. You can also control this effect using a shell modifier to change the thickness. The stronger the color intensity, the less transparent the material becomes. I'll skip the shell for now. I want the pebbles to stay visible, so I'll adjust the look using the fog depth instead. Fog depth controls how deep light travels before the fog color appears. Lower values tint faster and higher values look clearer. I like the result with a fog depth of 1.5. Both the pebbles are visible and the water has a nice solid color. Now let's adjust the metal texture. It will look better with stronger reflections, so we'll increase reflectivity and test which glossiness value gives us the best result. While we're at it, let's add the glass reflection to better evaluate the overall look. We can also slightly lower the refraction to make the glass less invisible and more realistic. If you want, you can add a subtle fog color to the glass too. I'll give it a soft aquamarine tint. Lastly, let's give the marble color a slight boost to make it feel a bit more vibrant. Let's see what's left to do. We need to make the roof white as well. and let's refine the wall using the same method we used for the others. There are two remaining marble walls in the interior, one green and one orange. We need to apply the same mirror tiling effect to both. First, create the orange marble material, apply it to the wall, and adjust it. Then do the same for the green one. Don't forget the stairs. You can tile them separately to create a different texture pattern, or if you want them to match the floor, select both the stairs and the base model, and apply a single UVW map modifier with the same settings. Let's also finalize the second pool. We'll place the sea pebbles first, then add the water surface. Apply the texture and V-Ray displacement modifier. You can copy the existing water model and adjust its size to fit, but don't forget to increase the segment count to maintain resolution for the noise effect. Lastly, let's refine the orange marble material. With that, we complete the first part of our masterclass. As you can see, it didn't take us long to create and texture the model. In the next lesson, we'll start working on the landscape by adding trees and grass. See you in the next lesson.